Hi everyone, it's Coach Fred here, and today I'm going to be talking about inverse functions. And so what I thought we'd do, I want you to take a look at what I have on the screen here. I gave you the function f of x equals x squared in tabular form as a table of values. You can see that we've selected those points we've been selecting often on the square, on the quadratic function, and all of the outputs, the f of x's that come out of that function. So negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9. So I'd like you to think for a second what the undoing function would be. Undoing isn't a math word, it's Coach Fred's word, but like undoing the square. So give yourself a second to think about it and ask yourself what function would get us back to x. Okay? Now, you might be saying, as you're thinking about that, well, there's no way for me to undo 4 to get back to negative 2, and there's no way for me to undo 1 to get back to negative 1. But there is a way for you to undo 0 to get back to 0, and undo 1 and get back to 1, and undo 4 and get back to 2. That is actually called the inverse function, and you might be saying this makes sense to you because you'd use the square root function. So the reason you can't undo 4 to get back to negative 2 is because that's where the domain on the square root function doesn't exist. So when you think of undoing a function, we call that the inverse function. Okay, so it will bring us back to x. That's what we're always trying to do, bring ourselves back to x. All right, I thought we'd look at it graphically. So, I love to look at things graphically. So here I've got a picture of x squared. So if the square root function is the inverse, let's look at it here. That's actually a picture of the square root function. Now I want to actually add the negative side of that, like the part of the graph that we don't normally look at for the square root function, and that would be this part. Now you might recognize a little bit about that. You might recognize that looks like a sideways parabola. So if you look on the left, you can see that I'm going to put some points on here. I've got some of the points on the graph here. Now, let's look at the points carefully between x squared and the square root of x. Let me actually remove that negative so you can see it. All right, so we see at negative 2, negative 1, it's undefined. But let's put in, we have 0, 0, 1. Let me change this x to 4 and see what happens. What do you notice? Now, what if I add to this? What if I add 3 here to the parabola? Let's see what happens when I add 9 here. So if you're looking just at 0, 1, 4, 9 in both of the tables, what I'm hoping you notice is that the x and the y's are flipped. And that's exactly what happens with inverse functions. The x's and the y's get, in essence, flipped. All right, I'd like you to look at the graph now carefully. What do you notice about the graph of y equals x squared and y equals x? What I'm hoping you notice, and it might not be as evident, is that it's actually, let me move this, it's actually a reflection over the line y equals x. If you look at that really carefully, you can see that all the points it's like a reflection. It's like a mirror image. Now, we've been talking about reflection a lot, haven't we? Reflection over the x-axis, reflection over the y-axis. We even talked about rotational symmetry when we were talking about even and odd functions. But if they're inverse functions, they're going to actually reflect over the graph y equals x. Now, you didn't have to write any of that down yet, but now we're going to jump to our notes. So in your note packet, we're going to just review inverses of relations and functions, okay? So a relation is a pair of two values, right? Now, when those relations have when we have a set of relations where every x has a unique y, we call it a function. All right, so I'd like us to plot each ordered pair that's given and then reverse the points like I just did, and let's see what happens with the inverse. Okay, so we've got 1, 0, 3, 1, 4, 2, 5, 3, 6, 5. So 1, 0, 3, 1, 4, 2. Okay, so now we're going to reverse the points. I'm going to switch the colors, and you might want to do that as well. So 0, 1, 1, 3, 2, 4. Be very careful. 3, 5 when you plot them, and 5, 6. Okay, so 0, 1 would be here. 1, 3 would be right here. 2, 4 would be here. 3, 5 would be here. And 5, 3, 5, and then 5, 6 would be right here. So I'm going to actually connect them. It's not a line. You can see that, right? So it kind of looks like this. I'm going to make that other one purple. So let's see. Kind of looks like this. Okay. So if we think about that, what is really important not only is that we flip the points, but they do reflect over that line that we just talked about. What line is each point reflected over? They're reflected over the line y equals x. Now, it's important to recognize that the line y equals x is a line that goes through the origin and has a slope of 1. So let me actually draw that line in. Let's see if I can get it neatly there. Slope of 1. Got to go through those corners. So something like that. There we go. And you can see that line x acts like, a mirror, and everything is just reflected over it. Okay, so if inverses are created by switching the x and y, then we actually can find inverse equations. Now, some of them you might actually start to see really clearly, but if I want to find an inverse equation, I'm going to switch the x and the y and solve for y. So we should know that an inverse of a linear function is going to be a linear function, it's just going to be different, look different. All right, so I'm going to flip the x and the y, and then I'm going to solve for y. All right, so we're going to add 2, and then we're going to divide everything by 5. All right, so that's going to be y equals 1/5 x plus 2/5. All right, let's think about that. If in this function we're multiplying by 5 and then subtracting 2, then in the inverse we're going to be adding 2 and then dividing everything by 5. That's how we got our inverse equation. All right, let's look at the next one. Again, flip the x and the y, and solve for y. So there's my inverse equation. And again, kind of should make sense. If I'm multiplying x by 1/3 and then subtracting 4, then I would have to be adding that 4 and multiplying by 3. So you can see how I'm getting that 12 now, okay? All right, now I can switch and make f of x equal 5x. Well, remember, f of x is just another name for y. So x equals 5y. So x divided by 5 equals y, and remember, x divided by 5 means 1/5 x. That one should actually seem pretty simple to you, okay? All right, I'm going to ask you to try D and E, and then come back and let's check them. Remember, always change f of x to y first so that you don't get confused. So go ahead and try. All right, for the first one, I got 2/3 x minus 1/3 equals y, or 2x minus 1 divided by 3. I want you to see if you can connect that inverse to the new equation, or to the original equation. And then the last one, I got 3x plus 5 over 2 equals y. I could actually leave it like that. That would be fine. Or I could write that as 3/2 x plus 5/2. But again, connect it. See the relationship. Spend some time thinking about that. And that's where I'm going to stop for today. Have a great day.